All right, this is going to be a long video because you know already that we turn blocks of aluminum into billet blocks, billet SMX blocks, billet SML blocks, billet SML heads, and billet SMX heads. So I thought, you know what? I've never done a absolute 100% all the way from how we clean it to how we assemble it to what's all going on one of my SMXs. In fact, my SMX for the wagon. So I'm going to show you how we're going to take these billet parts right here that we make in-house into a complete engine and into the wagon. So buckle in, grab your popcorn, sit down, chill out, and watch the video. I think you're going to be interested in that average engine for a wagon build right here. Might be a little above average wagon, but it's the average engine for the wagon right here. So we're going to start right from the very beginning on this thing. I'm literally going to show you how to hand wash it properly hand wash it. Now, first things first, this is quite literally Dawn. I prefer the Platinum because it's a little higher quality wash. Not really.
I like the little duck on it.
I like the duck. It's safe on ducks. It's got to be safe on the SMX. That's all I figured. So I literally we're going to just start getting the stuff wet. I have soap on it right now. Now you can't dink around on this too awful long. So one of the first things that we're going to do here, we'll just go through oil galley holes. And we're going to go through, because this is all the way down to the camshaft. So oil comes through the main, goes up to your main saddle, just like every engine in the world. And then it splits off and it'll either go into a different cavity, possibly down to the camshaft. That's what all this one does, is just down to the camshaft. Now when we go through this, so this hole right here, see it on an angle? Whoosh, that's the feed hole from the main galley. So the main, oh, that's right, you know what? I was corrected. This is the oil passage. So before you guys jump on me about saying oil galley, because the galley's in a ship, it's not in a passage, so it's oil passage. So the oil passage, this is the main oil galley passage right here. So oil comes from the dry sump pump, whoosh, right through here, up, and then through the entire engine. So that whole passage goes from front to back. These angle holes right here are the feed holes for the crankshaft. So we run these brushes down through here. Now, if you remember on the Average Joe build, I think it was on the Average Joe build, one of them, Joe said that, you know, he likes to, run the dingleberry hone down through the lifter bores. When we flip this over, I'll show you that we've already done that because we've already sized these and run the dingleberry hone through there because it kind of knocks off any burrs, does that kind of stuff. The oil comes up on an angle, just like this, whoosh, up into the crankshaft, feeds the crankshaft, and then it secondarily goes back down or up, because this block's upside down, to the camshaft. Now, Chevrolets do this. Basically, everything that has a freaking camshaft in it, that has one camshaft in it, does this. So you figure that out. So we're just making sure everything's all clean. Now, on the back cam bearing on SMX, remember, that's a roller bearing. I'll show you that in a minute. As soon as we're done cleaning this, it is a roller bearing. There is no Babbitt bearing right in there, so it doesn't need an oil hole. It just has the oil feed going to the crankshaft. That's it. Nothing going straight down. Well, I can show you some interesting stuff. I think if we do a real slow build like this, I'll tell you some things that you probably never even think about as we walk our way through here. It'd be kind of interesting. I just kind of get these pull holes. Now, there's a interesting thing about these main studs. Now, if you remember, these particular main studs are $82 a piece. And technically, they're not supposed to get wet. But the wet thing is they're not supposed to be sitting in water and allowed to rust, is really what it is. So you dry this all off and it's clean and perfect because every single methanol engine in the world is the nature of methanol. Did you know this, Nate? What does methanol draw out of the air?
It draws the water out of the air.
It draws water out of the air and puts it in the engine. That's why your oil really milks up. Is it's not just methanol, but it's also water. That's why we have the rust inhibitor and the SMOIL, because all those things, methanol in particular, especially in high humidity, sucks water right out of the air into the oil, and it's in the engine. So it's always in water. It just always is. And they make these out of head studs, and some of these head studs are just flat out and get in water sometimes. So anyways, that's just a little side note. You can feel dirt usually before you can see dirt, and you can see lint, dirt, all sorts of little stuff, especially if you got your readers on. You know, you can see almost everything. So visually looking down the holes is really actually probably the best thing you can do. You know, so now that is main oil galley. Let's run our brush through the main oil galley here. So just a longer brush. All right. And then we'll run it through this lifter bank right here, which is quite a bit tighter. All right. Then run it through here. Now the beauty of doing this, when you're doing this cleaning like this, is that you can then clean your freaking engine stand that nobody else cleans up for you. They just leave everything dirty and covered with oil. So we're gonna do that. Then we'll just physically look right down the oil galley holes. You'd be amazed what you can see. You know, you'd see burrs, you'd see about anything going through there. All right, so that's there. Kind of hit everything here. And this is run through the hot tank before. So this is the Renegade hot tank. So you might ask, why don't you just hot tank it? I already have hot tanked it. So this isn't really hot tank. It's the block sits still in it, and the spray bar goes like this around the block, or whatever you put in there. It's pretty nice. I do need I wish I had gotten the stainless steel one. So if you buy one of these, I recommend getting the stainless steel one. So maybe someday I'll be able to upgrade on that deal. But anyways, when I'm cleaning things, I'm also just always running my hands over everything, and I'm feeling stuff and looking at things and just making sure everything looks right. Like, you know, machine work looks right. Everything is just nice. Now, these are water passages here. I'll show you this. So, because we're going to get into cleaning up the cylinder bores here before they rust. Here, let me get some soap on first. So this is my cylinder brush, and I already have some soap in there. So all you do is put it on a drill. All right, and I'm mainly actually just doing that just so I can get soap all over it, so I can talk to you a little bit more. All right, so that's all soaked up. Part of the nice thing about doing, you know, nice hand washes is I'm literally, see? No burrs. You know, so I'm checking for stuff like that. Just make sure my guys did the good job and whatnot on machine, and make sure Brock didn't screw stuff up. But let's finish washing this, and then I'll show you the water passages and how they work. But that's passage, that's a passage, this is a whole passage. You know, passage here, passage there. I'll show you how it all works. But let's wash this thing up first. Now, one of the things I want to do here too is we also run a brush through every lifter bore. So we've already run a passage brush through there. So let's go in there, degrit this thing. Now, 90% of the time, the hot tank does a great job, and you might have to do little hand cleaning up all the time anyways. But I figured I was feeling pretty good, and I thought, you know what, I'm gonna actually do old school hand wash on this deal. So every hole gets every machine surface hole, tap holes will blow out, obviously. But and you can see there's actually, it's a little dirty water here. So it's getting something off of it. And it's been through the hot tank already. So that's interesting. And this is our distributor / cam sink hole. And this is just, our slot through there. All right. Now, cam tunnel. So I like to run a brush all the way through the cam tunnel, so the cam tunnel is clean. We'll get it from the front and the back because I don't have a long enough brush for this one. Now it's got a bunch of soap on it. All right, you can see it's getting a little bit of dirt out of it. I think I'll put a little more on it here. Get it really suds it up. All right, go from the back here. All right, there we got our sudsy going on. Let's get this again. There we go. So make sure you get in there really good. Now, I'm not honing anything. This thing is just a brush, okay? But it is getting stuff really nice and clean. All right. Feeling everything up. Feels good. Get this side. Now, when you do this, it is clean and there will be no oil on this whatsoever. So when I rinse this off and start blowing it off, I'll immediately actually wipe this down. I could probably wipe it down with a WD rag just to keep your cylinder bores from rusting because it'll be pert near instantaneous. And I'll do the kind of go through that main saddle and kind of just run the brush through there, period. And you can see that it's dirty in there now. And we'll clean the main caps and stuff just by hand. Probably in the solvent tank. Go there. Start rinsing this thing off. Making sure I feel all sides, looking at everything. There we go. Now, very proud of this whole deal, actually, because this is literally made right here. And you might think I'm all that in a bag of chips or something. Or you might think I think I'm all that in a bag of chips. I don't. I just worked really hard to make all this stuff happen over 25, almost 30 years now. Oh no, crap. It is over 30 years. It's over 30 years now that I've done nothing else other than try, building this business from nothing. Quite proud to even be able to make something like this and design it, make it, all that good stuff.
Wash it.
Wash it by hand myself.
Do you come in on the weekends and wash all the blocks?
If I'm not busy cleaning the freaking bathroom, yes. Now, the only thing that really is critical here on getting washed or dried real quick is just that cylinder bore. And then we'll go down below and start drying it. We'll start drying it from above, so all the water drains out of it that I just did there. Put on your safety glasses. Blow out your cylinder headboard hole. And I don't mind putting my hand. This is a little trick that, I don't know if it's trick, but I put my hand over it like this. And not only does that block it from blowing all over your face, I also feel and see if there's anything in the hole. That's just clean water. I'll feel it if there's dirt in there or chips or something. You blow it like this and it hits your hand instead of your face. And I know that it's clean inside there. Now, I already know these are clean because I've done this. All right, I'm gonna go get my brag of WD-40. WD-40 on a polishing cloth. So get yourself a real lint-free polishing cloth. You know, that you'd have for a detailing cloth or whatever for your car. Wipe the cylinder board, and you still get stuff. You've seen how much I brushed this block. Of course, probably, you know what, believe it or not, see how fast that is right there? How fast that actually starts to condensate rust? That probably is rust that's on there. Not really dirt, now that I think about it. Let's just wipe this all down. Now, if you're interested in seeing the how to hone stuff, we'll put a little link right up here in the corner on honing. I did a whole honing video on Cletus's big block Chevrolet.
Before you wipe that, you can really see the difference.
Yeah, you can really see the
Before.
difference. And after. Oh yeah, look at that. Needs help? Drop dead sexy. Needs help. But if you want to see what's going on with the hone and why, how it looks like that, why there is no grit in the cylinder bores because of the way we hone and what we hone with. We got that. Oh, RK, PK, VK, RA average. That's a roughness average is an RA number. You can go see a whole bunch about that kind of information if you want to learn more. Oh, that reminds me. There's a lot of stuff on our playlist in the Steve Tech area where I just specifically, before we did a lot of YouTube stuff, I put up these videos and made this stuff on pistons, rings, balancing, hone, cylinder head, valve job, resurfacing, all sorts of stuff that's in our playlist section. If you go look for Steve Tech, and you might see some stuff you're interested in. Lashing valves, degreeing camshafts, all sorts of crud. Now see, now it's just pretty much just dark. It's not really, not like that anymore. So you kind of wipe that rust out of it. That forms up in half a second because it's so clean.
Now, do you need to do this to the main studs as well?
Yep, I'm getting down there right now. I'm gonna finish blowing this off real quick. What the point of the studs is, you just don't want to leave the water on there. It is shiny and pretty.
It is shiny.
Then you're gonna blow down each and every oil passage hole and through every passage hole. You gotta stay on top of your cylinder bores because you get a little bit of water on them from doing that. Just to keep them nice. This is what I call a shiny mother trucker. Look at that. That just makes me smile. Gives me that warm fuzzy feeling. All right, if you come back here, I'll show you some stuff. Now you see there's a whole lot of stuff going on back here with the cam bearing area. So cam bearing comes up, hits this ledge, only goes that far. Then there's a snap ring right here at my finger that keeps the bearing from coming out. It's a big bearing. I'll go show you that in a second. And then these were previous grooves that we no longer use because we machined in a really nice camshaft cover plate that goes right there. So that's a new deal.
Do it.
Now that we got a perfectly clean block, and I mean perfectly clean, we're gonna do some ring gapping here. And our buddy Trevor here, one of our channel members, has came over and is helping me work on the engine. So he's using our new ring squaring tool. Show him how you're doing that, bud. Put the ring in the bore. Now, you squeeze it together when you put the ring in the bore because you don't want to drag marks up the bore. And push it down. Use the ring squaring fixture. Bing, done. Check your gap. Bada bing, bada boom. Now on this engine, and then when you're all done gapping it, he's already done gapping it. So you squeeze this together, okay? With my hands like this, I squeeze it together to pull it out. This is a top, or this is a second ring. And so your second ring on the SMX is 35 to 34 thousandths, right? 35 to 34 thousandths. And people ask, well, you say to make it bigger than the top ring. The top ring gap, when it gets hot, when the cylinder gets hot, the whole point of ring gap is that the ring, as it gets hot, let's pretend it's really big exaggeration, okay? It's cold. It's hot and running, closes up, okay? That's exactly what it does. We would like it to be, in the perfect world, it would be 0 or maybe 1/1000th from coil, from bind. Now when this, if you don't have enough ring gap, this gets butts up and then pulls the top of the piston off because it makes so much friction. It'll pull the top of the piston right off because it butts up, makes a lot of friction. So effectively, the second ring does not get nearly as hot. In fact, it really doesn't get hot at all, except just mainly board temperature, maybe just a little bit higher, as in block temperature. So it stays at 35 thousandths. Therein, it is a much bigger second gap than top gap. Follow?
Yep.
All right. And we gap the top ring at the same, but it shrinks up and makes it 0 or close to 0, and then the second ring is bigger. Okay? So, Trevor's got more work to do here. Get this thing rocking. Quit dilly-dallying around.
Okay.
Yeah. Sir, yes, sir. And then we have the tapered ring installer that we're going to use too. So if you guys want to, this is not your industrial, I'm going to use this for 500 engine builds kind of tapered ring installer. This is, hey, I need a ring installer and ring squaring tool because I want to build my own stuff, or I want to assemble my own engine. That's cool. Then you're going to gap rings and you want to assemble it. Well, you probably don't want to go buy a couple $100 worth of stuff. You can buy something cheaper.
Yep.
You know?
For the average guy.
For the average guy. That's right. After Trevor's all done gapping rings, we're actually going to start putting the cam bearings in it and start assembling this thing. So I told you I'd talk to you about that rear cam bearing. This is the rear cam bearing. Isn't that cool? Let me show you what a normal rear cam bearing looks like. This here is your normal cam bearing. That's a Babbitt bearing. So if you ever hear anybody say a Babbitt bearing, Babbitt cam bearing, that's what Babbitt cam bearing looks like. This is not your typical roller bearing. You'll hear people say it's got a roller cam bearing in it. That's not what this looks like. This is a different deal, and I would have to explain that to you. But when they're talking about a roller bearing, let me show you that. This is a roller bearing. So this bearing would replace that bearing. Forget about the size because these are two different bearings, but Babbitt bearing, roller bearing, Torrington roller bearing. All right. But this is a ball bearing, That's a Torrington bearing, Babbitt bearing, roller bearing, because this sets camshaft thrust. Let me show you the camshaft real quick. This here, 65 millimeters of pure S7 tool steel glory. There you go. Exactly like that. Just like so. So this sets the thrust. All right. So I can put this up here. So the camshaft can't go any farther back than that. And then we set the forward thrust on the front side. I'll show you that later when we're assembling it. That gets all covered up with our new cam plate plug. So that's the rear cam plug. Bolts in. Really super nice. So I'm going to install the first bearings through here, the Babbitt bearings, 1, 2, 3, 4, and then the big roller bearing that's on the camshaft right here is number 5. So we'll start installing that, and I'll talk your way through there as we're doing it. Alrighty, so we're over here. I got my cam bearing tool on one of the Streamliner Hemis because the SMX is right there. So my new engine right there. So just got it all cleaned up. I'm going to show you everything about cam bearings. Okay, and the cam bearing tool, how you install it, how you go about that. So this is cam bearing tool. All right, so has expandable collar right here. I'll show you that in a minute, and then has different size collets that expand. See how they're all four-sided there? For different size bearings. This is if you just have a more universal kit. So as I screw this together here, so you screw this, and you see that gap getting bigger and bigger. It's expanding that out. All right, and then this would press against the back side of the bearing. So I'll show you that bearing real quick. Now I have my actual pucks for these bearings, so I'm not doing that. But this is the way it would go. And then that little edge right there, it clamps onto the inside of the bearing and then presses on right there. See, on that ledge. All right, so what I have on these for my SMX is I have a actual driver tool that is the size of the bearing and the size of the housing bore. So the bearing is going to go on the tool just like so. So this is a little bit smaller than the OD of the bearing, so it can slide all the way through, and just slightly smaller than the ID of the bearing, so the bearing can fit on there. All right, so let's grab a bearing here, and I'll show you how we're doing this. All right, so first thing I'll show you here is on this particular block, and the SMX is like this, we've made some revisions in this whole area right here. So this is a bunch of material to support the sleeve right there, okay? So there's a bunch of material in there that I've left intentionally and reshaped this whole area. Now this is on our latest versions of blocks, and this is also, I can keep some more heavy material right there. Now the only problem with that is that, like, unlike a normal block, or most all blocks, you can put the cam bearing in there. I can push it in the hole, and I could turn it around inside there to get it aimed at the right direction. This, you cannot. It is too tight, and the bearing width doesn't allow me to turn it any more than that. The bearing is just too wide, so I have to drive the bearings in from one end, so drive it through this hole, into this hole. Now, I've already put this bearing in there, and I'm going to show you some stuff there. So I just have to put this bearing in, and then from the other side, I got to put this bearing in, and then we're going to put that roller bearing back here in the back, and I'll show you that deal. So let's we'll put this on our tool. I'll show you all this, and we'll start beating that in, and then we'll look at it up above and show you how it's going to go into that next hole. Something different here is I'm going to put this in with the engine right side up instead of down below, because since I can't get the bearing in there anyways, that's usually why you would do it. Plus you look down through the oil galley hole. On this block, I'm going to show you something. So here's how you would normally do this. You'd put the cam bearing in. It goes, let me tighten this up here. So it goes all the way up to that front cam bearing oil hole. Remember I showed you where these oil holes are right there? That is the oil hole that goes right straight down to the cam bearing. A couple things. This cam bearing has a 3-point oil system. 1, 2, 3. So a symmetrical oil hole system with a channel behind it. So it really does not matter where the oil holes line up as long as the channel is correct. All right, now typically you'd want to put that oil hole up so it lines up into the bearing, up into your oil hole squirt, or into your oil hole feed, unless there is some kind of channel behind it or in the bearing like this, then it really doesn't matter where they go. But if there's nothing there, you have to put that oil hole lined up with there. So I'll roll this over and I'll show you why I'm going to do this from the top. All right, so we got the block up right now. You can see here, this is a pinning hole, and light will come right through there, as you can see here with my flashlight. See that? that hole goes all the way down to the main, or right, actually it goes all the way straight down into the main galley. There you go. You can look there. Oh, see that? That hole is all the way down to the main cap. Now, what are these little threaded holes for? Well, these threaded holes right there, 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 and there are for is a cam bearing pin. Now, I've never yet had a problem with a cam bearing coming out of an aluminum block, but it is very common that they will pin the cam bearing. And what makes that so nice is on a bearing like this little groove, when it is in the proper place, will be right dead in the middle of that pin. And then I'm going to make a custom little bolt that will just go, when it's tightened up right there, it'll be just far enough and have a very small pin at the end of it that I'll machine into the end of that bolt that'll go pink and just locate right in there. That will keep the cam bearing from going front to back. It can't press on it. It can't touch the bearing, so it's just going to fit just barely in that groove. And I mean just barely in that groove. I'll actually just measure it, get the absolute depth of it, and it'll be, you know, plus or minus a couple thousandths of an inch. So it just fits inside that groove to keep, so we have a little bearing, little pin, just like my fingernail would be. Dink, just going right in there and holding it from going front to back. Now, the other thing that I have to do here is that these cam bearings, if you look right here, see if I can get the cam bearing, there we go. All right, it is going to be right there. Notice where the lifter bore is, and notice where this lifter bore is. All right, it's a little off. It is astronomically close, and I actually need to look, when everything is perfect, it does not intersect this cam or this lifter bore or this lifter bore, these two lifter bores right here. It is dead set in the center. So actually I can look at it from up here, look through the hole, and then I have to look down through the lifter hole and actually feel down in the lifter hole to make sure there's no overhang. Then I make my little set screw called a pin the cam bearing so it pins in there and can never move front to back. Very nice, very secure piece. So let's put the cam bearing tool on here, and I'll start beating that in, and we're going to go from all the way through the first one, then come right up into the second one, and we're going to start looking. I'll show you right down in the lifter bore as it's coming through. Sorry, I forgot to show you this. Now this is the tapered cone. See, this tapered cone slides, goes forward. I'm going to have I have my bearing over here on this end. Now, how do you know you're putting this in straight? Well, this tapered cone locates out here. The bearing is located on the journal itself. This cone keeps it from going like this. If you just have nothing there, you could be doing it like that, could be doing it like that. But with the cone stuck in the bearing journal ahead of it, this thing goes in straight. So I'm going to drive this into the first one. Like I said, it doesn't matter where the holes are at. You could put it in possibly a perfect place, but with a symmetrical 3-hole pattern, it really doesn't matter. Okay, beat it through the first one. Now that is going to locate the journal. I'm going to make sure that I'm tight here. I am. All right, now you got to hold that tapered cone in at the same time as you're hitting this so it doesn't get loose. All right, now we're coming up through our second one. Let's take a look right through here. Now you can see right there, that is our cam bearing tool. And the bearing, if I take this out, you see that little, that's pretty hard to see, but there is a very small lip right there. All right, here you can see, well, it's kind of pretty hard to see, but there is just the ever so small a lip right there. That is the cam bearing. So I need to put it in just a tick farther. We can see here that the hole needs to go, or the slot needs to go a little bit farther also. So let's put that in a little bit further. All right. And I can see the edge of my cam bearing tool. So it's not overhanging there. And there's a little burr in there, a little chip in there. Or on that side right there. We can look down in the top of it. We can see that groove is right dead in the middle of that hole. So I know that is correct. So like I said, I've already put one in the number 3 position and made sure that it was all right. But put one in a number 2 position. Now we're gonna put one in this number 1 position. The number 1's a little tougher to do because there's not a absolute way, because I put it in from this end. I don't want to put a cam bearing all the way through this just to get it up to here. So I'll put that cam bearing in from this side right here. And this wide cam bearing, it actually does a pretty fantastic job. It's really good, and it's going to be square in there. I'm going to use the camshaft to actually test and verify. Now you can see the 2 cam bearings that are in there already. We're going to put the number 4 cam bearing in there, and then we're going to put that roller bearing in there. Now what I'm going to do on this one here is, I mean, I've just put in so many cam bearings I know it's going in straight, but I'm going to just prove that out a little bit by putting on the adjustable one, because the problem with this tool is you're not going to be able to get it back through any cam bearing that you already did. And technically I could have put this in and then come in through the back without these ones in there. Well, no, I can't, because I can't put these ones in there if this one's in there. So I'm going to put the adjustable tool on it, which is this one. Come through the back side, and then I'll be able to put my tapered cone on it to just give it a little tap and make sure it's square. You'll see this thing come through. All right, see how that tool expanded out to it? Expanded right out to the cam bearing, just like so. All right, then I can hit it back here with my tapered cone in the rear cam bearing and just give it a little tap to make sure that it's square. Then I have a pinning hole up in the front. Let's go see if our pinning hole is lined up and looks good. Right there. And let me shine my light in there because I can't see crap. Looks like I probably need to go, there you go. Oh, I happened to get it lined up with a hole. The hole is just about lined up, just about perfect. As a matter of fact, because that one does not hit anywhere around or do anything, have any area problem, I'm just going to leave it exactly where it is. All right, so now I'm just going to drive in this 4th bearing. Not going to bother showing you that. And then we're going to come over to the big roller bearing. Now you don't want to let the cam bearing tool bounce on that cam bearing. You want to make sure it's nice and tight. And we got quite a ways to go. You can see right there that we got quite a ways to go on it. See if our groove is in there. Oh, groove is almost all the way. Gonna go just a tick more. All right. I believe we are right in there. And we can see our groove. Hard to see that for you, but groove is in there perfect. No overhang there. No overhang there, which means that it has to be perfect because the spacing in between the lifters is so close right here that this 800 wide bearing, so if you want to know the distance between this and this, it's
So I think it's actually like 825, something like that. So in between that edge and this edge, you say, oh, why don't you just move the lifters? Yeah, we can reinvent the wheel to do everything, but all you have to do is just put it in there perfect and it's fine. Actually works very well. All right, so our pin is in there really nice. I can see it. You can, a little harder for you. Now let's go look at the big bearing. Now this great big roller bearing here, this one, we're going to put in with, not even with the, well, we'll kind of lightly hit the expanding tool. I'll show you that. Now here on this bearing, because it actually goes up against a machined ledge, so this part of the camshaft goes up against that machined ledge. And so I'm going to be able to put this in here like so. Will expand out on the inside. Now it's not much press, there's not much going on here, so this bearing is actually designed for to have some forward and back load. That's actually what it does. So we'll be able to put this in quite easily here. All right, so we'll get that bearing started a little bit. It's just pushing against here. Still needs to go in the rest of the way. Okay, now I'm going to put my snap ring in there, which is a big old snap ring right there. That will locate that bearing, and then I'm going to come in from the back side and give it a little bit of tapping to come up against this, because that's what I want it to be up against. There we go. Now that snap ring is all in the groove. Knock it back into its correct orientation. There we go. Hey, now everybody's in the hole. Let's put a little bit of lube on this. We'll test fit this, and hopefully this thing goes in well. Use our old Driven HVL lube. I put oil on that journal and then just turn it. And when I get the camshaft almost all the way in, we'll flip this upside down. I'll put some more lube on it, and then we'll put it in there. So far, so good. That is nice. I'm actually holding this camshaft up from the bottom so it's not beating on everything. And we'll put it right here. All right. Back this up a little bit. Let's roll it over. Like so. Then we'll put a little bit of lube on this journal right here. That journal. And really nothing over there. This one. Actually, I'll move this camshaft back here just a little bit for you, which is no problem. There we go. Now you can see that journal in there. That is the main journal. This is the lobe. Another lobe right there. All right. Now, I'll just put this thing in. Stick your finger in, because I don't have the cam plate back in there yet. So stick your finger in the back of it, line it up. Give it a little bit of love taps, because it has a little bit of stiction just going into that rear bearing, the roller. And now, this thing's in there, and it's all the way in. Very nice. So super cool. Let's roll this over. We'll get a quick general inspection on where everything is in correlation to lifter bores to make sure there's no intersecting lobes. The lobe looks like it's in the middle of the lifter bore, etc. All right, so that lobe looks good, looks good, 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 which means the other ones have to be good, but I'll show them to you. Good, 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 Good. Now what you also could see, this is the one that the cam journal's on. If there was the cam journal itself, like the bearing journal was hanging in there, you'd be able to see it. So we're just looking to make sure the camshaft looks correct. So everything is nice. That's in the back. We got that bearing in, everything's good. Now we're gonna put our plate in, like so. We got a little bit of oil on that O-ring. Somebody put a wrong bolt in there. So I'm gonna go get the right screw. That is a cam bearing, how to install cam bearings in any engine. It's the same principle. This one just is a little more elaborate because it has more things going on. But there you go. We're gonna leave this cam this cam in it because there's no sense taking it out. And now we'll actually start putting oil galley plugs in and the rest of the stuff, but cam bearing or the camshaft can just stay right where it's at. Alrighty, you can see I got the oil galley plugs in. Next thing we're gonna do is we're gonna do this water. I told you earlier I was gonna show you how the water all works. Now that is one of our water plates that is covering up our block water ports. Oh, this goes on the other side. All right, there we go. There, that makes more sense. We actually machine it and do the final decking with these plates on. So each one of these is matched. Now, in all reality, this never comes off, ever. There's no reason to ever take this off. But I do need to have it off because we need to machine these channels. Okay, so let me show you how this works real quick. So this is our outer water jacket. This is the outer water plate. Every plate is O-ringed, but I do put silicone on it also because like I said, it's just overkill, but it never comes off. There's never a reason that I've had yet to ever take one of these off. So I'm just gonna silicone it on and bolt it on. Water comes in right through that port right there when the plate is on. It does have a P-hole that goes up into here, which is the front, the water channel, and then has a real slight P-hole that goes all the way across into our outlet side, but I'll show you that in a minute. So water comes in here, does go through here and goes over to that hole right there, basically. Very small passage, just for a steam vent, basically. So water goes whoosh all the way through here, comes to these three holes right there, which are crossover holes behind the deck surface, back here, through the block, through this whole solid section of block back there. Then these three holes are water crossover holes. You can look right through there. You can see my finger back there. That's light. So the water crosses over right through here. Three holes lined up with these. Bing, bing. Then crosses in. So we got obviously got to plug those. Then comes right through there. There you go. There you go. Then crosses all the way through this whole front channel area. So both sides of the block and both ends are cooled. There is no water that goes in between the cylinder bores, but there is hardly any except bone stock, no horsepower making mother truckers that have water goes between the bore cylinders. It's nearly impossible and it's pointless, doesn't need it. Then all that water comes right out through that hole. You can see the outside, which used to be the old inlet. So this is, I like to run it this way, all the way around and up through the inside, out. Just makes it a little handier. And we do that for both sides of the block. So pretty elaborate setup. And I need to put got the oil galley plugs in, camshaft in, got to put these water plates on, all before we can go any further. Got to grab the right plate. I forgot to mention that these are head stud holes too. These are custom to the SMX with those head stud holes. I'll put these screws right here because I can. And then we'll just put some red Loctite on these things, because obviously we don't want these things moving, coming out, nothing. I'm gonna put these screws in there, not tight yet, because I want to put some bolts in these things to bolt these downward to make sure they don't move. All right, and then you might be saying to yourself, Steve, you forgot one screw. No, this one screw right here has to be a 1024, because otherwise it will just intersect one of those cross holes in the water jacket. So that is plates. All the plates are bolted on, red Loctite and silicone on the main outer plate and the main inner plates. I did not do the front plates. I got to put the front plates on yet. I'll do that right now. Actually, I forgot about that. And you can see there, as we bolt these plates down, the head studs go through these. These are the intake port head studs, like I mentioned before. They go all the way through here. Well, we need to have these plates sandwiched properly, because that's how we machine the plates, and that's how the plate is going to be held down. So we don't want to, because of clearance in the bolt holes, you wouldn't want the plate to be sticking up, bolt it all together, get it all Loctite in, and then actually have this hold the head up, possibly. So you don't want to have that. So I put in the 4 bolts here to clamp the plate all the way down on the block, because they clamp down right here. So see how they pinch in right here? That way they're all the way down, they're tight. Then we put all the bolts in, and if you were here to feel this, you would go, oh yeah, that thing is like perfect. Yeah, it's perfect. Can't really. Perfect. It's perfect. There you go. It is camera guy perfect. Nate says it's perfect. This side over here is also perfect. So that's all good. So these are permanent. I can take these bolts out. Oh, I'm going to go show you. So these are for camshaft pinning. We talked about the pinned cam bearing. So what I'm going to do is go take these screws over to the lathe, and I'm going to go machine the little pin in the end of this. So this will go in. I'll put red Loctite on. Ultimately, when I get the perfect height for it, it will screw in, tighten it up with red Loctite, and it will go inside that cam bearing groove. So the cam bearing has a groove all the way around it, and the pin will go beep, just like that, and then the bearing can never move or come out. Now, you might add, well, how do you know how deep to make it or whatever? Well, it's actually pretty easy, because if I tighten up this screw and the cam bearing stops turning, that's too long. So we're going to I'll measure this, and then I'll get an underhead dimension, and I'll make it as close as I can right off the bat, but I'll be able to verify it by actually just putting it in and having it go down and do it. So let's go do that real quick. We'll make these pins. We'll get these cam bearings pinned in. We'll take these out. Then we're just going to flip this thing over. I've already measured main clearance and stuff like that. We have lots of videos talking about main clearance and how to properly check things. If you'd like to see some of that stuff, make sure you go to our playlist and on Steve Tech, and there's a bearing video in there. And we do those occasionally. So we're going to start putting the crankshaft in it. We've already checked for our clearance on the connecting rods, and we had to grind one little spot in each bore. So everything's clearance there. So we're ready to start putting this thing together, and I'll show you pistons and rods, crankshaft.
If you want to see a thing of beauty, these are fantastic. But they're so astronomically expensive crankshaft. But it's what's needed in order to hold all the horsepower. So, I mean, you're talking 50, about $5,500 crankshaft. Just not cheap, unfortunately, to do this level of your average wagon engine is a little above average. Gotta tell you the truth. And then I'll talk about pistons, rods, and we'll go through and I'll talk about all that stuff and rings. So first, let's go do this little pinning bolt that we need to do. All right, so we're going to measure down here and to find our cam bearing slot, and just for I can show you exactly how big the slot is by hitting 0 right there, and then I can feel that little slot is right there. Yeah, so that groove is not much. It's only 11 thousandths deep, that groove. So I got to be on my A game. So let's measure this up. Okay, so 6.642 underhead length is definitely a max length. So you can see right there, that's what that is. So I'll cut a little off of it, and then we're going to make a point up here. Actually, I think I'll cut the point first, and then we'll trim that point down, keep on trimming it down until it's perfect and fits inside that groove. To show you the cam bearing from the outside again, that's what that looks like. That groove is 83 wide. We'll verify our depth here. Well, this says that groove is 20 deep, which makes a little more sense, to tell you the truth. Yep. So a little bit of measuring inaccuracy there. Yeah, 18, 19 thousandths deep. And that pin, so I'm going to make a little pin that goes right into there, into that groove. So we got that in there. We'll spin this up. I think I'll spin this a little faster. There we go. I'm doing this all just by hand. Okay. We'll check our size here. Oh, 107. So I got to make it smaller diameter. It's a little tough to do. Kind of got to sneak up on it and just take a few thousandths at a time when the diameter is so small, it just is so weak. The piece of material wants to climb up on top of the tool bit. And then break off. $72. All right, now, so we are 740. Oh, so it needs to be 100 thousandths shorter. Want to think how we're going to do that. All right, so I think I'm going to take this out and grind it off because I don't think I can actually machine that little. I don't have good enough tooling to just machine that tip off of there. So if we need to be 642, we'll just say 635 is probably going to be perfect. So I need to, yeah, you got to drill that off. Or machine that off. Okay. Well, let's go over there and do it. All right. So we are 670. 633 and a half. All right. So I think that's pretty good. And then we got to put a little chamfer on it. All right. There you go. Let's try that. All right, so let's thread that down. I think it might be just a tick long. Now here, I'm quite literally, I'm just spinning the camshaft while I'm tightening this up. Oh, sweet. Ta-da! Yeah, perfect. All right. I think I got my math right. It's tightened up all the way. Now, interesting little side note is if I left this bolt out, and we're gonna make the other three and red Loctite them in, because they, within reason, they never have to come back out. None of these bolts come back out. So Loctite the bejeebas out of them, so nothing ever comes out. But interesting to note, because of that oil channel back there, if this bolt was not in there, it will spray oil right straight up. It'll bleed off all the oil pressure. Well, not all of it, because it's got a lot of pump on it, but it'll bleed the oil pressure and just have a little stream of oil just shooting straight out of there. All right, so I'm going to make the rest of these, and then we're going to flip this thing over and start putting a crankshaft in it. And then I'll show you more about, I don't know if there's anything that I can show you about the crankshaft that you wouldn't just know or figure out. It does have knife edging. So they knife edge both sides of it. Sometimes you'll see an airplane foil on the, I think they always knife edge the front side, and sometimes they'll do an airplane foil or just a radius on the back side in rotation. So it's rotating through oil in one direction. So here, so it's correct on your camera like that. Even thinking about the reverse, it's going like this, okay? And so the leading edge, this edge, would be cutting through oil. So there's different things you could do there, but it is so minimal, and we're not hunting for 1 or 2 horsepower. We're just always trying to keep stuff alive. All right, so let's get after it. All righty, so I got the last of the screws in. I have all these cam bearing pin bolts in, and everything's good. So now, as you see right here, we're at 4 hours and 25 minutes of just prep time to start assembly. So does not even remotely cover. That's not machine time. That's no building the block. That's none of that kind of stuff. This is just assembly. So just washing it, putting the cam bearings in, getting the plugs in, taking care of a little bit of clearance work there. That's minimal stuff. So now I've got Trevor over here who's going to help gap the rings. So he's going to gap rings, and then I'm going to start putting stuff together, flip this thing over, start putting the crankshaft in, keep on counting on the clock, see what this thing ends up taking. Now, main cap's on, and something I like to do is see that I've sanded one side of the washer. Now these have been on a couple times, but I just wanted to, this is just the shiny smooth side that goes up towards the nut. This is the coarser side that goes down on the cab. That helps that to torque correctly. What it does is, a lot of times if you have put too much oil down here, or if it's too smooth and shiny, both the washer will try to spin on there and it just doesn't torque correctly. We want to slip the nut right here on the thread and there, and have this washer not do anything. So someday I might actually put a permanent hat washer in these caps. That probably might be a next upgrade. I've done that coarse sanding on each one of these, and that goes on the cap side. All right, so you see how I just hit the hammer on there, and that just kind of sets our thrust bearing, even though I don't use that, because we use that whole rollarized thrust bearing here up in the front. Let me show you how we did that. All right, so I thought I'd show you guys again. If you've seen this, sorry, but if you haven't, I think it might be a little interesting. So I showed you on this video up here of Garrett's on Cletus's rollerized thrust that we put back here. So we showed you how we build all that and how we do that. So on this is a SMX style or a ProMod Hemi style, Top Fuel, whatever. So the first thing is we machine up this ring right here. Now this ring is also for a spline drive crankshaft or with a keyway crankshaft. So this is the ID register for Torrington bearing. All right. So the bearing assembly will go on there right like that. And then this whole cage assembly is what that all pushes against. So that little ring right there pushes up against here, spins, and that controls the forward thrust from the torque converter. 99.9% of the time, it's only a transmission or some kind of torque converter problem, something in the transmission, something behind the motor that pushes the crankshaft forward. All right, so I'll show you how you set this thing up and how we do this. So first thing first, now I just have the ring on there, big flat blade screwdriver. We're gonna push the crankshaft all the way forward. Now I'll show you what's all going on here. There we go. Now we're gonna push this back. Okay, push it forward, push it back. Okay, so we got 7 thousandths of thrust bearing clearance right there. Now what I'm going to do is, that is its natural spot right there without the thrust bearing on it. So what I want to do is when we bolt the thrust bearing on it, it's going to push this crankshaft just a little bit, like, I don't know, maybe like right about there. Something less than the thrust that it already is. That way, see how it is. We know that the crankshaft is all the way forward. All right, crankshaft's all the way forward. So we want it to not hit the back of the bearing. Right now, it is right flat on the back of the bearing. It's getting pushed forward like the transmission's pushing it. So we want the thrust bearing to capture that and keep it from hitting that bearing, because it puts so much load. The potential is to put so much load on that thrust bearing, it knocks the thrust bearing out. This is in extreme conditions, and honestly, it's probably, if you have your torque converter pressures, if you have everything correct and you're not hanging out the drive for like 8 seconds on the two-step, where it's just, for 8 seconds, that's a big deal, okay? That's pressure, heat, everything's happening. This will save you if you get hung out to dry, but most of the time you can get away with a stock thrust bearing. All right, especially the F bearing that we put in some other engines where brand new, where it's a ramp and pad system. So, anyways, enough said about that. We are all the way forward with there. All right, so our indicator is still at 0. I take this out and we put our bearing in there. We're going to bolt this on and see what it goes to when we try to push the crankshaft forward again. A couple bolts. So now we can see that it is hitting that. That is as far as I can get it to go forward. We go backwards and it's still exactly the same. 7. We go forward. And now we can see that it is hitting by at least 1 thousandths on just the thrust bearing. Now, if we want to adjust that from here, what I would do is I would actually lap this, and I think I'll go do that because I want to get a little more in there. I want this, when I put that thrust bearing on, I want that thrust bearing to be pushing it back to like close to about 1 thousandths to 1 thousandths and more or so. Dang it. It's like touchy. Okay. So, anyways, I want it to be a little bit more. So we would have to actually lap this. Now, once this is all set and this is all done, this is kind of like a match thrust bearing assembly for this engine and crankshaft. If it was too tight, and would need to be, if I like pushed it all the way back, well, lapping this surface right here, trying to remove it going that way would be the wrong way. At that point, then what we do is I have to take a little bit of material off of this ring right here that's on the crankshaft. So it's all these little stack up clearances that you have to do to get this thing to go. And just to be perfect and nice, I'm gonna go lap this thing and take a couple thousandths off of it so it pushes it back like in that 3 thousandths range. So let's go lap this on our surface plate and wet dry sandpaper and come back in here and hit it. And you can also see that this is all machined into the block. This whole area is all machined into with the cap on. Everything's permanent. So it machines all in, and you can see, you know, the exact shape of this machined into the block and cap. All right, so let's go lap this up a little bit. Now this is a granite surface plate. It is as flat gets. There is nothing flatter. I don't know how they make it, but they make it flat. All right, let's go clean this up and try this. All right, so now nothing has moved, nothing's changed. Let's see if this thing has made it change. All right, let's see where we're at now. Yep. Well, it maybe gained a 1/2 thousand. So I'm gonna go back there and we'll lap that out some more till I get it to, I would like to be at least 2, somewhere in between 2 and 3. And that way I know that it would have to move and push through that bearing a couple thousandths before it would even touch this. Now it would, if it gets far enough, it would end up using both of them. But this is bearing the brunt of the load. This would be first, pushing through it, has to push through this in order to even get there. That's perfect, that's what we want. So I'm gonna go do that, get this thing all set up, and then we're gonna come back and put this thing together. All right, now putting the angle bolts in, the splayed cap bolts. Same thing, around the backside with just a pattern to make it coarse. Alrighty, so right through here, I did not realize that my microphone that I thought I was doing a really good job of doing quit working. So I'm gonna have to talk your way through here. Now what I'm doing is everyone, I have the main cap's just snug down, crankshaft turns great. So as I'm starting to torque these main studs, I always sit and feel, make sure everything still feels right. It turns exactly the same, nice and free as I torque each individual one. That way I'm just kind of verifying that there's not an issue, a problem, something going on, maybe a bad bearing or just anything could be possibly wrong here. So I literally just check each one and spin it each time. Now these big main studs here, these things torque to 150 pounds. 150 pounds on the big center studs and 95 on the outside. So, and these goldarn studs in the middle are $82 each per stud. That's per stud. So, anyways, just torque all this stuff up and just always keep spinning as you're going along, just to see if you find a spot that is a little funny. And the thing just spins like $1,000,000. It's just great. So I just go back over, double check, make sure everything's torqued, and we're ready to rock and roll here. All right, so here you see that I'm just putting a little bit of lube on the rollarized thrust bearing. Now this is exclusive to the SMX, and it is done on some Hemi stuff, but exclusive for turbo cars that spend a lot of time on the torque converter and charge pressure issues and charge pressure problems. Now I've already said all this, I've already done all the clearancing, I already showed you all that. This is just me doing the final assembly of it, torquing the bolts, and now we'll move on to looking at pistons and rods. Now here is pistons and rods. I don't honestly remember exactly what I was talking about right here. Might have been talking, I have no idea. But
It was probably something relatively important. I had a serious look on my face right there, so it was probably something like important.
Might have been the one time you said something.
It might have
about
been the one.
Bryant.
Might have been the one time. Oh, it might have been. I was talking about Bryant Goldstone right there. That's weird. But yep. Oh yeah. Yeah. Well, nope. I'm not rub. No, I wasn't talking about Bryant there. Oh yeah. Knock on wood. That would be Bryant. But anyways, I think I was talking about just the overall pin fitment, everything that goes on there. Now putting the bearings in here. Um, Now the upper bearings are always the one that take all the abuse. The lower bearings never take any abuse. And I still don't know what I'm saying here. Oil, well, keep everything dry. Do not put oil behind it. Don't put Loctite in or anything like that. Now that pin button is all SMXs, and I try to do pin buttons as much as possible now because depending on tune-up stuff, tune-up issues will knock the spiral locks out of pistons, which is really weird. So that's why we do that whole pin button thing. I do know that we're going to talk about here in a second. I'm probably talking about how the cap can, or the connecting rod area kind of actually goes oblong. I did a video on that thing before. But here on the crankshaft, this is interesting. So here I'm showing you what we call overlap in the crankshaft. So the overlap in the crankshaft is the distance between that rod journal and the main journal. So like right here is dead center of the main journal, and we want to make sure that we actually have overlap where the main journal and the rod journal are actually, if you drew a straight line all the way across, they would actually be the same. There would be no air in between the rod journal and the main journal, right where I'm pointing my finger. So that whole area right there is all solid. Actually solid up to about right up through that area. It's just all solid through there. So that's what gives strength to the crankshaft. And that's why you'll see other crankshafts, big stroke crankshafts, have problems. All right, so we're going to, the pins, everything's in here. Put a little bit of lube on the pin bore, all that good stuff, jive. So this is in there real nice. Guess I had some little questions about the what locates, keeps these things from turning. I notice, see how that goes here. If I push on this end of the pin, let's see if I can get that. See how that works there? All right. These are not hitting, they are just slightly smaller than what the piston is. So they have a little bit of clearance here. It is minimal. It's about 5 or so, I'd say. But these will come out and they can touch the cylinder bore. No damage. They're aluminum. The piston's aluminum. It touches the cylinder bore, right? And you can see there it comes out past the ring a little bit. The ring goes in there. The ring is what keeps this from rotating. Now, you can't put, if you don't have a ring to locate the button, they will not put a button in there. You can only wait, the only way you can get it then is to do a spiral lock or some kind of lock system. But the only way we'll do buttons is if something that can keep the button. That way it's shaped like the cylinder bore. It doesn't come out and wear a groove or do something stupid like that. This is shaped to the cylinder bore profile and keeps from rotating, because if there was no ring there, it would rotate and cause damage. Otherwise, another way you can make that work is it'd have to be solid, and you have to make a little pin button right here because it would be rotating, and that's why you can't do that. All right, so let's get the rings on here. Now this is that Napier steel second ring. Show you something a little interesting here. They actually, it's pretty hard to see. Let's see if we can, you can see the little shiny line there. They actually go in there and machine in, let's see here, there we go. They machine in this actual little hook right there. So imagine they got this in some kind of machine that's sitting here like this, and the teeny tiny of end mill comes in here, goes zip, or however they do it. Not exactly sure, but that thing is shaped like a hook, and if you are scraping like this, it literally feels like a razor blade going over my finger. Here, let's do it this way. See, it's actually just cleaning my finger up. In fact, it's filling that up full of skin. Sorry, there you go. That's skin off of the ring. Now, if you put that in upside down, it scrapes all this oil off the cylinder bore and puts it up, and it'll go right past the top ring, and it'll smoke like nobody's business. Now, top ring, these are engineered at chamfer. Remember, chamfers go up unless it is otherwise indicated. But that chamfer is actually an engineered thing into the piston ring that is helping it stay round as it's being compressed. And as it's loaded, it stays flat because of that chamfer. Very small little chamfer right there. Very small. All right. So chamfer up. All right. I don't bother loading this all up with oil and all this other bull crap. Not going to do that because we're going to put a little bit of bore or oil in the bore. Piston comes down, scrapes, and acts exactly as it does when it's running. So I would never pour oil down the cylinder bore and then start the engine up. Well, there's no sense to do it on startup either. Does not add anything to anything. Now, especially on here, these are a hard anodized piston. Same thing they do in the nitromethane cars. The ringland is hard anodized, so it's harder than woodpecker lips and keeps things from wearing also. Okay. Yes, you can rotate these. Rings rotate. I talked about that earlier. Rings rotate as it's running, so they'll always keep on turning. Where you put them, honestly, it doesn't matter because they rotate anyways. But just out of normal, I put the top ring away from the intake pocket, even though it goes by it anyways. So I put that more like at 10 o'clock, and then I put the second ring at about 2 o'clock normally, but that really does not matter. Oh, good question here. What does this oil ring actually do, and why do we need this ring? What is it that is really doing all the oil control? Okay, fairly complicated. This, if this ring isn't in there, if that second ring is not there controlling oil in these kind of applications, not talking about some single ring piston, not talking about some motorcycle engine, whatever, not talking about that, I'm talking about here. If that ring is not in here with this oil ring here, it will have uncontrolled oil. It looks like a diesel rolling coal, except it'll be all white smoke. Okay, it needs the combination of both. If it all, actually, within the reason, you could probably live without this one and just have that one. But one thing that this oil ring is doing is it takes a big, massive bulk, any oil that comes right here and gets in there. Where what's going on here is that the piston actually has, that's what all these holes are for. So it's a twofold deal. Oil that's getting scraped off gets in this ring, the expander and the two rails, and gets caught in there and is oiling the cylinder bore and controlling oil by putting excess oil back into here, and vice versa. So oil comes up here, cylinder piston goes down and is scraping oil off the cylinder bore, is lubricating the cylinder bore all through these holes. So it's kind of like does it both ways. So it's scraping off excess, and it is excess, and putting it back inside the crankcase through these holes right there. Okay. And it would get oil up through here because oil is splashing up here, and would oil that cylinder bore. So it really is not the main function of that oil support ring or oil rail, two rails and expander is not for 100% for the oil. It is probably more for lubricating the cylinder bore. The second ring is the scraper, and that is scraping the oil, whatever gets past this ring or whatever is there, scrapes it right off. So almost think of that like a squeegee. All right, now let's put some bearings in here. So these, I'm doing something a little bit different here. Oh, wrong one. Is that I'm doing a standard Clevite Mala 1512V upper, and they have their own. These ones are a coated bearing, but it's a different kind of coat. All right. Then it's not meant to take up any clearance. So I got these all right here. Okay, 2, 4, 6, 7, and one of these already. That one of these already had one in it. Nope. The cap side bearing, which never gets any, really gets no beat, because remember, cylinder pressure is pushing down on the piston, which really loads this bearing here. The only thing that loads the cap side of the bearing is when it's pulling the piston back down, which can be a lot, which can be really detrimental, but is not generally the big ticket item of makes problems. Okay, so this one is a line-to-line coated bearing, which is absorbing a little bit of my clearance and is giving me, these are a thousandths thicker, so it is giving me a little less clearance only on the cap side, standard on the rod side. Take our microfiber cloth, wipe off our surfaces. This one here has got a mock-up bearing in it. Take that out, so that's not the one I want to use. You tell him, dog. You tell him. So I'd like to just lay everything all out, nice, neatly organized, in order that I'm going to put it together in. Everything's clean, oiled up here in the threads. Everything's consistent. And that one piston's backwards though. There we go. There we go. Just like that. Everything facing the same way. Everything the same orientation. It just makes for better, easier assembly. All right, now I'm going to put just a little bit of oil, just a couple drops. That's all it needs. Don't need to give everything a complete oil bath and soak stuff in oil. It used to be a long time ago where everybody thought you needed to, it was a great thing to soak everything in a coffee can full of STP oil treatment. Didn't do anything except make it smoke like freaking crazy when you started it. All right, so first thing we do is we're gonna lube the cylinder bores, and all I do is just put in a ring of oil just like this. Like I said earlier, I mean, soaking your piston rod in a coffee can full of oil, that's totally not necessary. All that's gonna do is just make it smoke like crazy. Okay, so no point in doing that. This is as much oil as it needs to lubricate the rings and the skirts for that initial startup. Because as soon as it starts and has oil pressure, it's flailing oil everywhere. I mean, that's just, and then it's back into a normal position. All right, so we'll get our crankshaft lined up there. I did grab a bolt, bounce bolt. Now, something I have actually caught people here doing, I've caught Kyle doing it, I caught Joe doing it, is they would run a bouncer bolt in there and just let it bottom out instead of stacking up a bunch of washers on it, so it will not bottom out. And that is just asking for danger, because what happens when you bottom out a bolt, sometimes what will happen is sometimes it'll mess up that thread and tear all the threads out of it when it comes back out, so it screws everything up. Do not bottom out bolts. It will screw something up. And you bottom out the thread in this $5,000 plus crankshaft, and somebody named Steve is going to be mad. Mad. So when you're never going to do anything to the thread when you have all these washers stacked up on it, and it just is nice. All right, so we're just getting everything prepped up to work on the assembly of pistons.
So we'll come over here. We'll grab a piston and rod. We'll grab our tapered ring installer. Crankshaft is down on the bottom. I loosely orient the rings. We already just talked about that. Now, then we'll do it this way a little bit. I like to put this on and get the rings set in there first. There we go. All right. Make sure our rod is turned correctly. Now we're just going to lightly tap this down. Now I like to tap just a little more, pretty square, but I'll tend to go over here just a little bit, right here, because I'm tipping the rod away from the counterweight. If you hit the rod piston over here, it makes that rod, bottom of the rod, go that way. So I tap on this side, making the bottom of the rod go this way a little bit. So I kind of gear towards that side. I'm not hitting this thing hard. Everything's real smooth. I mean, I'm basically letting the weight of the, well, here, I'll show you. Piston, I'm just going to drop the hammer and you look at the piston. So that's just the weight of the hammer knocking it down. Okay, so you're not beating anything in there. If you are beating something in there, you better stop and take the piston out, because you might have a ring that is bad, has like slipped out of the groove. Usually it's oil rail ring or oil rail that will have come off and it's cocked sideways. It'll ruin it. You're gonna have to put a new one on it. Is what it is. We already had oil on. You see me put assembly oil on the connecting rod side. So we'll put this cap on. There we go. Just run this up. Now these are already properly oiled with the proper oil. They do not want you to use a Molly lube or anything special on these. And we just use this very lightly. Just get it up till it's snug and that's it. Like that. Okay, we're not putting any torque or doing anything to it. Make sure everything moves back and forth. It's free. Looks good. Now I've had this mocked up because, as you see by our runtime here on the clock, I finally got the crankshaft in it. Finally got the rod and piston in it. And it just takes a long time to, this isn't, adding up time that I'm not physically working on. This is time that we actually are working on it. Okay, putting things together, fitting things, making everything right. So it takes a long time. The days of you and your grandpa putting an N350 Chevy together in the afternoon ain't like that with these kind of things. It's just, there's just so much more going on that you do it. And it would probably, and honestly, even a bone stock 350 Chevy, if I was putting it together from scratch, where we had to put cam bearings in, where we had to put soft plugs in, oil galley plugs, it honestly is probably, to do it right, is honestly an $8 deal. Honestly, so don't feel bad. Grab the next one. Now, obviously my rods are in on the correct orientation, which is kind of a big deal, as in, if they're not in the right rope, not in the right orientation, it's going to be broke pretty much instantaneously. Actually, it wouldn't even turn over right. So, all right. Now I just guide it with my finger. So I don't know, see my finger down there, Nate? So I just grab the cap, and I like to just guide it with my finger. Then I don't have some screwdriver or anything else. It's like dragging across the crankshaft. All right, there you go. Bada bing, bada boom.
Done.
Now we'll put a cap on. Now you might see them going in order. Trevor is here and helped me lay this stuff out. He laid it out 1, 2, 3, 4, 5, 6, 7, 8. Well, this is all the odd side of the motor. So this is 1, 3, 5, 7. So that's why I'm grabbing every other one. Before somebody calls me out on it and says, "You put the wrong one in the hole. I'm pretty sure you put number 2 in the number 3 hole." All right, goes up nice, feels good. Roll it over to the other one. Now, in any tapered ring installer, you do want to be, like I was saying, consistent, nice taps. I would never use anything other than a tapered ring installer. We're trying to get things figured out to have the tapered ring installers that with 3D printing, just so you could use it for your engine, not professional one, not one that you use 500 times or 1,000,000 times. When you're putting it in there, you got to be careful that everything is lined up, and if it stops or just all of a sudden gets to a tight spot, don't beat it in. Figure out what's wrong with it. That should be the motto. Don't square peg a round hole, or you know. All right, come back down, and we come around to torque these all up. These are a 625 volt, meaning that these are a really expensive rod bolt, and yeah, so these are ARP 625 plus. So those little stupid rod bolts are, oh gosh, they are 50 some odd bucks a piece. So you got 16 of them in there. Crazy. And they torque up to 115 pounds. So that's a 7/16 bolt that you're torquing up to 115 pounds. Now, oh, I know you're going to ask, why don't you use a stretch them? Well, they say not to stretch them. They give me a torque dimension or torque figure with the oil, and as long as they have it figured out, so I do exactly what they say. Now, if they gave me, there are some companies that will just give you a stretch number, and the stretch number you would do here. So this is a stretch gauge. So you'd set it up, and you would measure the bolt, how thick or how long the bolt is on its own. Oh, you know what? I think just for kicks and giggles, we'll just do this. So I'm just going to show you exactly how this actually works, even though I'm not going to do it this way. We'll see where it actually ends up being and how much they stretch. But what I was getting at is, even if they only give us a number for the stretch, I will stretch one rod bolt. I'll do it exactly the way they say. And if I'll measure it, and I will record the torque on my digital torque wrench. And I go, okay, cool. It took exactly 115 pounds to get it to stretch this far. Okay. I just go through and use 115 pounds and stretch them all. Or I'm sorry, and do it all like that. If you want to just check everyone and stretch everyone, makes you feel good about it, more power to you. That's cool. But it's a long bolt. Ooh boy. That's a really long bolt. This kind of particular gauge has a ton of spring pressure in it because they don't want to have any deviation on how somebody checks it. Okay? So we will say that is 0. All right. Now, just for kicks and see how it's in there. And there's a little point for a gauge to go in there, and a little point on the end for it to go into. Just to verify that they're all the same length, I know that they are, or at least that they should be. There you go, 0. They better be the same length. They can do that. So what we'll do here is we'll put the rest of these in, and then we'll stretch gauge, we'll put it on, we'll check it untorqued, and then I'll go ahead torque it, and then we'll measure it, and you'll see that it has elongated, it is stretched that bolt. And that's exactly what torquing does, is it stretches the bolt so it gets it to a clamping stretch number that it won't loosen up, but not too much that it overstretches and starts to shear it apart. So another thing you might want to do if you're working on any kind of engine that has bolts in it, or I'm sorry, studs in it, is as you're hitting it down like this, you don't want those rod bolts hitting the crankshaft. okay? Because it will ding them, and then you're gonna have to take the crankshaft back out and have that filed and then repolished, and then your crankshaft has a ding in it. So the best thing to do is you can put like little rubber hoses on the rod bolts, and if you really wanted to, you could put long rubber hoses on the rod bolts, and they would actually guide your piston and rod in. Since these are bolts, there's nothing to guide here. I guess if I wanted to, if I didn't want to just put my finger on here and guide it myself, I guess I could put some kind of long rubberized, rubber coated bolts in it or something, some really long thing. That's really overthinking it, but I guess you could do that. But for, like a 350 Chevy or any kind of rod, stock rod with bolts, you can put some kind of rubber hoses on, something to protect the threads. Because if you do hit the crankshaft, you're gonna have to fix it. All right, I thought I'd show you this thing too. You might be asking, in old days, you used to have to use feeler gauges, like 2 sets of feeler gauges in here to set the side clearance so the caps lined up correctly. No longer so. Why is that? Because they have come up with, MGP does this, they have a full circle serration, and so these things fit into the full serration receiver groove there, and so it locates perfect every single time. So there's no need to put feeler gauges in there like that in order to set the cap on properly. It can't slide or move it or do anything. So that has been a real good thing. Now you want to be real careful if you have even putting these rods and pistons in. I'm guiding it down with my finger and I'm just barely tapping to get things to go in right. You do want to be careful that you don't hit in any engine. You want to be careful that you're not hitting anything on the way down. So like if I was hitting this piston rod on the way down and it happened to hit right here on the surface and I hit it hard, you would smash that serration and then you're screwed. The serration, if all of a sudden you got these really nice little serrated grooves that fit perfect like this, kind of like that, and now it's all bunged up and it sits like this, it won't torque right, it's going to be wrong, and it's going to end up failing. So that's one of those things. You're really not going to hit or neck the crankshaft with an aluminum rod, but you could smash those serrations. Other companies, and there's good other connecting rod companies, so don't get all hung up on. I've used these rods since the original owner and founder of the company, Mike Giannone, was there. And he was the original founder of GRP rods. That's what the G is Giannone Racing Products. They make a real good rod still, different ownership. R&R makes good rods. I use both of them. I just happen to always just been brand loyal because that's just what we've done since the beginning. So was using his rods. Michael's dead now, but I still use his products. All right, now we're going to measure that rod bolt. It is loose. You can see it's loose right there. Okay, it's loose. So we'll put this in there. This is going to be a real mother on this style rod. This is probably the other reason why I can't get in there to get that. I can't go down to do it the other way. All right, let me show you on another rod. I don't think I'm going to be able to do it now. This is what the bolt looks like when it's in the rod, and so I can't quite get there, and then it's too long. This is no problem, but I can't see. This is all bottomed out. I can't get it to. All right, I don't think I can. I might have to have it about there. That's close. I don't think we're gonna be able to do this. We'll make it as long as possible, but I don't think we're gonna be able to get it. So obviously you can see I've never done it on these bolts before. No, I'm not. See, I can't get it to do anything but hit there. I'm not sure if I. All right, this is dedication to you guys. I'm gonna go grind on my tool to do something I don't care about doing for the sole purpose of showing you how something works. All right. So remember this in your will or something. All right, so we modified the tool so we can do this. All right, so there is untorqued, unanythinged. So I had to move everything here. So we're all right. So that's 0. All right, so here is the paperwork for it. This is the bolt we have. This is a 2200 10U. It's a 7/16 bolt, 625 plus, 115 pounds. They don't even give you a stretch number. They just want you to do it this way. All right. Also, somebody had just asked me this because they saw that this is from the rod company. Do not leave rods torqued either in a box or in an engine for a period longer than 6 months without any heat cycles, which basically just means without running. If the rods are not in use, all rod bolts need to be loosened to take the preload off the bolts and then retorqued prior to use. That would be the ideal way of doing it. I have customers like Rocky Boulder, like Matt Hobbs in particular, Zach, SOB Motorsports, Dave Heckheis. Have some customers that have had engines for a long time that have not gotten running yet. And we'll be talking with them and have talked with them. Like, hey, if you guys are watching this video, yeah, what I'd like to do is I'd like you to pull the bands off and just untorque them and just retorque them back to where they need to be. I think that's good. You know, if they torque back up, they're okay. If they don't torque back up, they're bad. So anyways, we've just measured that bolt. Let's get the old torque wrench here. Now you always want to do this in one motion, so don't go. Okay, it's one motion. You want a nice sweeping motion in it to get it to read correctly. Now I do get the other side. I will take them to, like 50 pounds, just so I can make sure one's not like stone cold loose. So I'll just get this like 50 pounds. Well, 50 pounds. Okay. Then this one, I'll get it to about 50 pounds or so, and then I want to do one sweeping motion. All right. So I'm at, let's double check my number, 115 pounds. Okay. All right. All right. Now, let's see how much the bolt has actually pulling itself apart, or i.e. stretching. Huh? That's quite a bit. 10 thousandths. That's quite a bit. Usually I've seen these things in other bolts. They'll only stretch usually like 5.5 to 10 or 5.5 to 7.5 thousandths. But that's 10 thousandths. But that number's right. Interesting. 10 thousandths. So that's how you're going about and doing that. And now we got more information that we know. And this is also why you want to use, don't F around with different oils. Only use the oil or the lube, or whether it's ARP lube, whether it's peanut butter, whether it's pressure lube, whatever it may be. Only use the bolt lube that the rod manufacturer says to use. They got it figured out. They clamp this stuff. They know what it stretches. They know what the proper clamp load is. Don't change the lube, because you could really screw something up. If I put, for example, they only want you to use the 50 weight oil. Well, luckily that's all I use. So 50, 70 weight oil. If you use the ARP lube or a really slippery lube like the peanut butter lube, you torque it to 115, it's going to stretch maybe 15, 20 thousandths, and all of a sudden you got a broken rod bolt. Big deal. Okay? So only use the correct manufacturer's lubrication there. If they tell you to use oil, then just use oil. It's no big deal. And I'm going to go back to putting this on its side because it's just awkward enough to be kind of a bugger. So we're gonna just torque this up. All right. And I'll get the rest of these all torqued up. And then we're gonna move on to putting the camshaft in and degreeing it. All right, and just most of the time, honestly, I don't ever put a little yellow dot on stuff that I mark, but I kind of make the other guys do that so I know that it's torqued. I make the general assumption that I don't F that up, but there's always a possibility that I do. I have, when I have F'd something up like that and forgotten to torque connecting rods once when I was a kid, and permanently scarred me for my entire life. So it usually is never a problem. But I thought, oh, I'll mark this in there because it's a good idea. Take a little paint pencil or take something and just mark the somewhere on there, just so you say, yep, I did it, I did it, I did it. And you know somebody can come in there and go, oh yeah. It's like if I tear apart your engine and I take the pan off and I see those yellow marks, I immediately assume, oh, he torqued them. If I don't see yellow marks or white mark or some kind of mark, I'd think, I assume he did it, but you never know. All right, so let's roll this over, and now we're going to start working on our camshaft. And now we're going to be putting on our cam gear drive. So let's show you how this is all going to work here. All right, so our top gear up here, 11 bolt pattern, has all these little infinite different settings on it. Now this is obviously just our bottom gear, no big deal. That's all right. Now here you see though is our idler setup. Now the idler on these is actually very nice and is actually machined into and put into the block. So that whole post, this is just the idler post, presses it or just fits in there, locates. So I mean that would locate mainly by itself. So it's dowel pinned on the back side all by itself. So it's very rock solid, sturdy. Actually a very nice deal. And then it has 3 bolts there. They're going to hold everything on. So now I'll get the 3 little bolts I need for that, and we'll put that together. So very, very sturdy, stout little bugger. Find my bolts. All right, I think these are my correct bolts. Make sure they're not too long. Never want to bottom out bolts in the hole. That is correct. Has 3/4 inch coarse bolts that hold that in there. We'll red Loctite those in also. Give this a little love tapping in. There we go. Now it's set in there nice. We got Loctite on bolts, so it will just go right in. That hole right there must be a little bit shorter because it's not going all the way in. So I need to go shorten up this bolt just a tick. All right, so now we got that bolt short enough. There we go. Now it feels right. See, it's down. It's good. It's good. Everybody's in there. All right, now we're gonna put on this assembly. So it takes a hard washer in the back. Whoop. And it takes 2 bearings. Right here is what the idler gear actually rides on. These are 2 inner races. So first inner race there, bearing, inner race, bearing. We'll put a little bit of lube on it. Handy dandy lube right there. Then we can put our idler gear on. Hard races fit inside the idler gear just like that, nice and smooth on both sides. So that outer, that shim plate back here will fit right inside there. I'm not going to put this on permanently because it would go just like that. I'm not going to put the snap ring on that holds that assembly together because it's much easier to put this all together with the idler gear off and then put the idler gear in. So we're going to roll the engine up on top dead center. We're going to measure that. And then we're going to put our bottom gear on and our top gear, and I'll show you how we do that. Now, let's put our bridge on here with my special aluminum magnet bridge. Now, for this particular application, I don't need exact. We're not like degree in the camshaft. I'm just trying to get it in the right spot. Just top dead center. So that top dead center is fine right there. All right. Now, I'm going to get the idler gear. Or I'm sorry, the idler gear's on there. I'm going to take the idler gear off. It's just going to give me a little bit of a hassle right now. So we'll just take it off. Leave that whole assembly all together, just like it is. Put that down here. I need to put a key in for my bottom gear and put on our top gear. But what I need to do first is I got to put in our indicator on the number 1 intake lobe, which is right here, because I want to turn that camshaft so that it is at top dead center. The camshaft lobe lift is at about about at 100. All right, let's see, there we go. And being exact is not the problem. That just gets me in the general range of where it's going to be pretty darn close, so I don't have to guess. Because why? Because there are no marks on a gear drive, because they're infinitely adjustable. Therefore, they can't just put dot to dot. Okay. All right. So let me go get a keyway for this real quick. Alrighty. So I got my Woodruff keys, and I'm gonna put that in there. There's actually 2 Woodruff keys on these, one on top, one on the bottom, just 180 degrees apart from each other. Go back up and move my crankshaft anyways, just so I can get this to a reasonable spot. This is a brass punch, so they are much softer than everything that I'm hitting. All right, let's put our bottom gear on. Ah, crud. Won't go on over the bolt. Figures. So I'll take this off. Alrighty, so I got the keys in it all the way down. I just had to beat them down a little bit further. All right, there's that. We'll just drive that on just a little bit more. Got my little special driver tool here. Drive that bottom gear all the way on. Everything looks nice. Now we're on top dead center. We're at 100 thousandths of cam lobe lift, and I'm going to put my gear on. Now this is always the tricky part. I'll show you this real close. So we got the top gear on here. It's loose. I got it lined up with the pattern that it, or I'm sorry, with the holes right now. We're still at 100 thousandths of lobe lift at TDC. Now we should be able to put in my idler, and I'm trying to turn it as little as possible. It won't be exact, but we'll turn this as little as possible. Hello, hello, come on. Because that's like 120, 130, 140. Come on, where's it going in? You know what, we're going to do this the other way around. Let me go back to about 100. I know sometimes it ends up being like 120 or something like that. Let's put the idler gear on. I think it might be a little bit easier here. It's trying to engage into the crank. All right, so now you can see here, this is what gets to be the problem. So to line up, now you see that the bolt holes are no longer lined up like that. And so now you are continuing to turn the gears. Now this is the new motor, so I've never had it together yet. And every time you turn to a different tooth, the teeth are not lined up with the, there we go, teeth are not lined up with the pattern. So that is very close right there. You saw how far it was. I just moved it one tooth over. And I think I can get it to go right here. Yeah, there you go. Now that ends up being, now we can get that in there. And now we are 90 thousandths of lobe lift there. But I think that's going to be close enough to just degree this and that. Now, we're going to put, now we go through the whole thing of doing our normal degreeing, checking where this is at. And if it's off, whatever amount it's off, I do this exact same thing where I just keep on, I move the camshaft. Well, I'll just show you. Really? When you hit things with your hand, it's called a hand burn. A hand burn? All right, everything's all set here. And we got the degree wheel on. So now we're going to come up here and we're going to show you how you do this one more time on degreeing the camshaft. So we need to set our top dead center marker. We're going to do that by going both sides of where the piston stops. So you can see here, we're going to start, I always like to go in one motion. And it doesn't really matter what number you take, but usually it will be somewhere in the neighborhood of 50 thousandths. Let's set 0 here. All right. So that's 0. And I roughly set my degree wheel. We're at 12. Let me get it in there better. We'll go to 11 because I think it's going to be pretty close to that. Now we'll continue in the same motion so there's no backlash. It gets to top dead center and then it crosses over. And as it's coming back down, go to the exact same spot right there. And we are at 13. So looks like 12 is the magic number. There's 10 on one side, 13 on the other side. I'm sorry, 11 on one side, 13 on the other side, which puts us at 12. Let's get this up here. There, that'd be 12. Now we'll recheck this again. All right. Go to 0. There we go. We're at 12. Go over, back down. We are at, oh, darn it. Went too far. Right there. And we are at 12. Okay. So that looks good right there. Now we got our degree wheel is in the correct orientation. Now we start looking at here. I had some questions on asymmetrical cams versus symmetrical cams, degreeing cams. You guys are way overthinking it. Let me show you on a camshaft here real quick. All right, here is a camshaft. Now, when we are finding all the cam grinders, every cam grinder in the world tells us where the center line of this lobe is. That is a known fact of where the camshaft is at, okay? The center line of the cam, which means that point right there. They measure that point by going over here, splitting the exact difference, which gives you the center line of the lobe. I'm only measuring and doing exactly as they grind the camshaft. So I feel I like to just always do this right here, find the center line of the cam by going over here, splitting the exact difference right in the middle. That is the center line. Then we move the camshaft back and forth. Now, I did hear some people, or saw some comments on people saying, oh, old school, we just put them straight up. lined up the dots. A, there is no dots here. B, that doesn't mean it's straight up. That just means that you lined up the dots. You hope that the camshaft grinder put the dowel pin, located everything in the exact same spot, that the timing chain company put the spots in the dots in the exact same spot that they're supposed to be. A lot of variables there to just take on account that it's doing, that it was right. Now, what we're doing here is checking and adjusting to put it in where the camshaft manufacturer wants it to be, where it's recommended to be, or where I want it to be recommended to be. Okay, so that's a little bit more information on that. So now we're going to go here. The lobe is coming up. Doesn't matter how big the lobe is. It doesn't matter where it opens, where it closes. Doesn't mean anything. All we want to do is we're going to select a number approximately 50 thousandths before the peak lift of the lobe. And if it's not 50 thousandths, it doesn't matter. Oh, look at that. It's 45 thousandths. Now we go over there. Okay, let me go back just a little bit and get back to that 50 number. Okay, and always do things in one direction. Don't go back and forth. I'm always going in one sweep. That way there's no backlash. There's no sweep or no backlash in there. Okay, so there is 0, which is 91. Right, I can tell you right now this is off. So I'm gonna have to move a lobe or one tooth. Now we're gonna go all the way over. There's peak lift. You see it's still going up. Now, which means it's in the middle of that lobe. So roughly, it's right there. Roughly, okay. So now the lobe is turning. So we're going to go over to this side of the peak lift of the lobe. So we go to 0, right there, and it is 163. Yep. So 163 and what was it? 92? Yeah, we were way off. So that's 250 something. So we were literally one tooth off. All right. So let me move this one tooth that is highly retarded. So I'm going to pull this gear off. I don't know. I need to move. Yeah, no, we can keep it there, and we'll pull the camshaft out and move it over one tooth. Let's see here. I want to do this. Dang it. A little tougher than that because it's in that rear bearing back there, giving me a little bit of grief. Oh, here we go. This is where I like to do this with the bottom gear. Okay, so this is where I like to do this with the bottom gear. I mean the idler gear. So we'll leave this here. I'm going to take the idler gear off. So I'm trying to hold everything all together all at the same time here. Move this thing one tooth. Advance it one tooth. So here we go. There is one tooth. Oops. Come on, get in there. Dang it. Probably just screwing this all up. Trying to film this at the same time as I got a camera in my way. There we go. Camera in my way. So, all right. Now let's try that again. Oh, I moved way too far. I moved that way too far. Well, maybe not. 65. Go to peak. Go back to 0, 65, and 135. And nope, that's going to be 200, which puts it at 100, which is, again, 1 tooth off. So let me see here. I got to figure out a better way of doing this. I can just get the camshaft gear out far enough. I got to go backwards one. Felt like it moved a lot. I must have moved it 2 teeth instead of 1. There. All right. Backed it up 1. Let's do this again. All right. Now let's come in at it. 0 and 78. And 149. All right, that equals 113 and a half. So counting for a little bit of retardation as it is self-retards as it's running, that's perfect. That's exactly where I want it. So you can see it's not a real big deal. It's not the end of the world, but there is just a little bit more entailed here. And it is always absolutely best to just be measuring all this stuff. So that gives me there. Now I'll take this all apart. I actually will probably put this up on top dead center and mark everything. So just in case and have to mark the camshaft where the camshaft's at compared to where the top gear is at. And that way I can keep track of all this stuff in case I have to take it off. There's top dead center. All right, now this is the front bearing assembly, and the fuel pump drive extension goes right here. This is the drive hub I just showed you. So this will have a Torrington bearing that goes right here. Okay, got that. That be right there. This goes in just like so. So the camshaft is bolted right here. The camshaft is coming up using that thrust bearing right there. Comes up against that roller bearing, and everything rolls together. There's more bearings in here than law allows. All right, so we'll put this all together. I'll put this on here. We're missing a couple bolts, but we'll be able to do, or 3 bolts, but we'll be able to do everything, including setting this all up. We'll grab the front cover. This is all part of the front cover assembly. Now, in all reality, there's probably no need for this many bolts in there, to tell you the truth. This is quite a bit of retention there. Consider most everything in the world has some form of 3 bolts, or I'm sorry, yeah, 3 bolts or 4 bolts maybe. A dowel pin and 1 bolt maybe, something like that. We'll get some red Loctite on these. Now, before I forget, I got to put that snap ring on there. That would be no bueno to forget the snap ring. And we'll get the torque wrench, torque those up. Snap ring on. There we go. Now we'll torque this up. All right, when the other 2 bolts get here tomorrow, I'll put those in. Now comes our front plate. Now you'll notice too that this plate has a nub built into it This is dowel pinned on to the block, and this is for the receiver. This is a receiver hole right here for the other side of that idler pulley. So that idler gear post is like astronomically well in there. I mean, the only thing that's holding this on right now at all is just the post. See? So that is a tight machine. It has a very light press that goes in there, and O-ringed on, so there's no gasket that goes here, so it stays very consistent and nice. Now I got the O-ring on the cover, dowel pins in, bada bing, bada boom. Fits nice and snug. Oh shoot, you know what? Then I forgot to put the, there, I put this all the way on. Yeah. But I forgot to put my front cover seal in there. There you go. Nice and tight. All right, so let me take that back off because I need to put the seal in it. All right, got my front cover seal in there now. There we go. All right, now let's get some bolts in here. Alrighty, so front cover is on. All right, now we're gonna set our camshaft thrust. We're not gonna put this together permanent because I'm missing 2 bolts, even though it really doesn't need it, but we'll put our thrust bearing on here, like so. And then we'll put our plate in. Put some bolts in that. All right, so tighten up this cover just like so. Oh, there we go. It has a metric crap ton of clearance, so we need to fix that. That looks like about 50 thousandths clearance. You can see how far that moved forward. And so we'll take this cover back off. I have it back all the way back again. It's a little snug in that rear bearing just because it's all brand new. So you just have to move it. But there's no shims on this, which makes sense, and which is what I figured. There we go. Now we'll shim this up. All right. That looks like about 10 to 15. That's good. So we're going to call that good right there. All right. So now we're going to put, I'll take that. I need to take this back off and put my O-ring around the back side of this. Get the final bolts in it and bolt that on. All right. Now you can see here we are continuing to climb up on the hour usage, because one thing that I just decided to do is like, oh man, you know what? I didn't remember to have these main caps anodized. I'm going to anodize these main caps. So I took these caps, actually had Joe take these caps off, and these are hard anodized. I totally forgot to do that. Wanted to make sure that we did that. So we got the main caps analyzed, got the running clock up here in the corner. It is astronomical. We have, and then I have the 2 bolts that I was still short for the camshaft, and we're gonna put those things in. Of course, they changed colors, so I got 2 bolts that are the wrong color. It'll drive me crazy forever, but it is what it is, and because they're like $12 a piece. So, anyways, now we're gonna bolt on. Everything's done. Pretty nice, cool. Super happy with all this. You might ask, oh, Doesn't that hard anodizing change your clearance? Minimally, about half a thousandths or so on the main, and I already have excessive clearance on mains anyways because that's the way you build them. So does nothing to it. Just bolts on. Everything's great. So that's all good. Happy about that. Now we're gonna put on our oil pan, put in our 2 bolts. Then we're putting on the dampener, and I knocked out that's my location on a where I need it for my engine in the car. Nobody else's, so somebody else might have a different spot where they have a missing magnet. I'll have to figure that out if I ever loan them my other engine, but tough crud. Or they can pull their own pull the balancer off their engine and put it on this, the other engine, the spare. So we are trucking right along. So we're gonna put this on. Still got to put in the front water plates, and then I'm gonna start putting the cylinder heads together and continue on with the build. So we are finally getting there, and I'm gonna have this done this weekend. So I figure the way things have been going, it's probably another 80 hours worth of work to get the engine back the rest of the way together, the way things go for me, and another 120 hours considering I got to run around and do everybody else's stuff or work with everybody else. So anyways, I'm just kidding, but we should be getting there. But you can see every little thing just can take so long to change, modify, do. It's just astronomical what all happens here. We are looking good, and we're gonna keep on going.
One almost complete short block as soon as I put this balancer on. All right, didn't show you that, but just put on my balancer. And for some reason, I'm going to have to change my timing pointer. It's really not that big a deal, but it is off 4 degrees. God darn it. So I'm going to, I think I might have Brock redesign this, but I just needed to mark it for right now so we could keep going. And all right, so you see time. Now we are finally at 100% complete short block. So now I'm going to, sorry, just seen some dust on there, is wiping off. Now it is cylinder head time. So I'm going to start putting these cylinder heads together. On these are brand new. So these are brand new heads, brand new engine, used engine right there. All right, that's the backup. So I'm going to start working on the just setting these up for our spring heights. Actually, had one of our channel members came over and helped me do all this. So I'm just going to double check his work real quick, make sure that everything's cool. Our installed height, which is, where's that at? I got my height mic in here somewhere. Where did it go? Nope, it's not here. Well, we got our valve train. We'll get to that as soon as I get the cylinder heads all together. Just verified that top dead center with my bridge. So these are those, just astronomically nice. The valve train on this engine is one of the things I'm actually, really proud of, and is different, and is just really good. I'm gonna have to go grab that height mic, and I'll show you how to do that. I had one of our channel members come over, and he helped us out, and by putting these together, and just wanted to double check some stuff. So checking installed height. So just so if you guys don't know, so installed height is the height between the retainer and the cylinder head. So I need to measure that height right there with the actual components it uses, because that sets your spring pressure. Now so imagine if your spring is all the way compressed, A, you would have lots of spring pressure, and B, it might coil bind, or it might have a lot of problems like that. So we need to set this to get the proper height, which we can call installed height. And then from that installed height, then we can take all our numbers of open rates and how much spring pressure it has, all that other happy stuff. So this one right now is 2080 is my installed height here, which is my minimum side, because I just did this one and put the valve spring in there, which I got to take back apart. and because my maximum is I want to be in between 2080 and 2100 install height. That makes the camshaft profile meet the valve spring. So how much lift is there is meeting the valve spring. All right. So that is all set. And then showed you this whole deal with, oh, let me back up just a little bit. The always make sure that when you're assembling cylinder heads, it doesn't matter any cylinder head. So even though we're working on something really expensive here, all principles are exactly the same. So it is, you still need to put a little dab of oil on each valve as you put it in the valve guide. So a little dab of oil. These have oil on them. So I just put dab of oil on it. Everything's clean. Everything's nice. Put it up in there. Then I come in here, check all your installed heights, set everything, and then we'll flip it up, and then I'll start assembling stuff. Now, just to refresh your memory too, if you haven't seen or you had more questions on the sewer lid deal. So this is the sewer lid lash cap and keeper assembly. All right, and how this is working is you see the little ledge right there. All right, that keeper comes in here and grabs that, just like so. Okay, so when we put this together, you actually have to put the lash cap on first. So I got this, I'll have the spring in there. Lash cap goes on, keepers go in, and then the spring comes up and holds it all together. Now, the reason for this lash cap is twofold. If you have titanium valves, this might not be known, is a steel valve is actually flame induction hardened on the tip, and that's what keeps it from wearing out. If it is not flame induction hardened, it has to have a lash cap on it. They cannot flame induction harden the valve stem tip on a titanium valve. So a titanium valve either has to have a hard insert in it, a hard tip, which is they actually machine, they drill a hole and they push a hardened steel tip in the end of your titanium valve, or you put this sewer lid on there, or a standard lash cap. This is not normal. Whoop, this is not a normal lash cap, okay? Normal lash caps aren't retained in there and kept in place by the keeper. So that's why you need lash caps. Titanium valves are too soft. You don't have a lash cap on them. They usually won't. I've had on accident not put a lash cap on something or thought it had something different, and it pretty much doesn't make it off the dyno because it'll just beat a round groove right into the end of the valve stem from the roller tip. That's why we need that, and the reason these are captured is that we also want the lash cap to be pressing on the valve and not actually pressing on the keeper. It cannot press on the keeper. If this lash cap presses down on that keeper, it will dislodge the keeper and the keeper comes apart. All right. So if it pushes down on it right here, it will dislodge it and it'll come apart. So when these lash caps are on there, the keeper is holding the retainer down. It's pressed in there. The only thing that it is doing with this lash cap, honestly, is just keeping it from coming off. It's not doing anything other than just capturing it and keeping it from coming off. Because we have to have this. So if you ever have a rocker arm failure, or you have some little silly failure like that, or just the valve lash adjustment's wrong, something like that, the lash cap has enough room to come out. A lot of times it does. And if a standard lash cap that isn't a captured lock or a sewer lid like this, sewer lid is just a nickname for it, then all of a sudden that lash cap is off. It's down in your engine somewhere, okay? And your valve train is beating your valve to death, all before you know it. So that's why we have these sewer lid style lash caps. All right, so I'm going, and then I was not paying attention. I was talking to people here, primarily. Camera guy. He's a temporary camera guy. Nate's not here right now. You're going to be working on doing a YouTube series yourself, right?
Mm-hmm. Yep.
All right. You can turn the camera on here. All right. Tell me your name.
My name's Thomas.
Thomas.
We're working on a interview series called The Good Guys Garage, The Garage Files. Gonna figure it out. Might Might get Steve on it. We'll see.
All right. We'll tell you more about that later.
Yep.
So Thomas is doing a little bit of videoing while he's been beating me up for information and see how they like to go. So we do stuff with the Good Guys Garage. So this is Good Guys Garage son.
Mm-hmm.
There you go. So anyways, I'm going to continue to put this stuff together, and then we're going to be putting these cylinder heads on the engine and finally making some progress, I hope. Now this this lash cap is actually turning. Therefore, I know that it is perfect. Now sometimes the lash caps will be really tight. They might not turn, but that's exactly how that all goes on and goes together. Alrighty, and here we have one assembled SMX head. Water plates, all those plates we've had to put in, seal up, because remember how water all flows in this. Gonna put all my studs in. All of these studs here are all just to hold the rocker arm stand down to the cylinder head. All 7/16 studs. Put in the O-rings and our port blocking right there. Access to the head bolt hole. Other water plates right there. Everything on. Our fire rings, SMX hoops, I like to call them. Chambers, everything's rock and roll, ready to be done. I'll get this other head together, and then we're going to start assembling the heads on our short block. I need to put in our dowel pins right here, dowel pins, and start putting in our head stud kit. Then we'll put in lifters. Camshaft is all done. All that stuff is good. So we're getting there. We're making some progress. All right, you can see here we got the cylinder head on just sitting there. Our copper head gaskets. Remember that we have that receiver groove and fire ring. We put a little bit of silicone up here just to seal up a little bit of oil. But everywhere else, there's no water that goes through the head gasket. Why? Because there's no water that goes through the deck surface. It's all solid. Just makes things much more rigid. And that's why we come out of the block with water there. Out. Remember, it goes in here, out here, in there, out there. So totally separate systems. And you can see here in the head stud kit, we get this from Point One. And they are really nice studs because we have had problems with studs before. But the only problem they do is they put a really nice looking P1, let's see if we can see it, P1 logo on there, but no way of putting the stud in. So kind of got to think about that for just a minute on how I want to do that. Most all of it's not a problem, but it is a little bit of an issue trying to service the engine when you can't get the head studs out, because most of the time I'll actually take all the head studs out in order to take the head off, because it's easier than pulling head up all the way off of the studs in the car is to get all the studs out of it. So I'm going to work on that here for just a little bit, kind of think which way I want to do this. Two things here that have slowed me down is that we got new studs from P1. If you recall, they had a great stud, but they didn't have any way of putting it in there. And then I told you, check it out. I'm going to go back there, make Brock put this in the machine, CNC machine, and he's going to cut a 7/16 hex
on each one of my studs, so we can bink, put these in there, run it down with a stud because they didn't put an inside one there for me. But the inside ones, anyways, if you've ever, they're just a small Allen wrench and they always suck, and because they strip out and they do all that kind of stuff. This is a real world like 7/16 nut. This is hardcore. So I'm actually happy about this, but it literally took to do all of these head studs. It's a 3-minute cycle per stud with setup time, or then add setup time, taking in and out. So I mean, you got basically about 6-7 minutes per stud. Okay, so there is half of them are in already. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You got 36 studs at, let's just say, 8 minutes a piece. So 36 studs, 36 times
Like
8
250
minutes.
minutes.
Huh?
250-ish minutes.
250-ish minutes, yeah.
4 hours.
It took all day, basically, but we had a little bit of time in it. So, is that what it is? 2 minutes? Yeah. Yeah, so right around there. So, I mean, even just figure 5 hours. So, 5 hours.
In machining studs that are already made.
Machine studs that are already made. It is great, but that is what it is. So, I'm trying to get them to, that's just not what they do. They have a hard time doing that, but you cannot get these heads off in the car because there's usually drag and drive cars. Very hard to get the heads off. There's usually something here, but if we can get all the studs out of it, the head just goes pink, gets out of the way. So that's just one of those things that we're having to do, and one of those extra deals. Then, so we have that. We're putting head studs in here. I just have the heads on with the outside bolts, outside studs right now, just to clamp everything down. Talk to you about the gaskets there. Head studs. Now I'm doing my crossover tube. You guys have quite a questions all the time. People, if I don't talk about it, people will ask about it. So I'll just talk about it again. For the people that don't know, the way the oil system works on SMX is we have a main galley that's hidden here. You can basically see the main oil galley is right here. This main oil galley crosses over and feeds this lifter galley. But there is nothing that feeds this lifter galley. Passage, oil passage. Forgive me on the galley thing. So what I do is I have made a internal line that just is a crossover line to go from this oil passage over here to this lifter oil galley passage on the front and back and here. And that provides good equal flow for both lifter banks. So that is what this line is for right here, is a oil crossover line to feed oil to this lifter bank. So I'm just making that go in, then I'm going to start putting the lifters in it, and I can talk to you a little bit about lifters and why I chose those lifters versus some others. And I can show you some other things I got that we could be doing that I'm not done here with my lifter bore inserts. You can see the whole little video and whole little clip. Maybe I'll show a little something right here on the lifter inserts that are actually in the spare engine. So if you come over here to the spare engine, this was a repair. You see right there, that little bolt right there that is Loctited in, and that holds a complete insert in. So I can change that lifter bore just by taking that bolt out, pulling the whole lifter and damaged bore out, and put a new one in there. Now, could I have replaced everything and put all these insert bores in there? Yes. I could have, but I don't think, and I could have done it on this. Maybe I'll end up regretting not doing it. I don't know. But we'll talk about it more as I start to put the lifters in. Alrighty, so now we have, the lines are on, my crossover lines to feed this oil passage. Now, lifter-wise, this is our lifter. We have Morel makes these for us, and they worked with us, wanted to work with this body style, everything. Other good lifters out there really like Isky stuff. I like the guys over at Isky. Just happened to be, these guys had the lifter and could work this for us out the quickest, and once they did, we just haven't changed. Now, why don't I use you should put a 1032, or actually it's 1031, 1031 or 1100, whatever. Great big lifter, blah, 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 keyway, everything like that. Couple of reasons, okay? First, those are excellent lifters. Isky makes them, Jessel makes them, obviously. They're excellent lifters. But the way they work compared to this has a open oil passage all the way through here, okay? Each lifter is in the middle of a oil passage, a large oil passage. So if this set of lifters ever like came out like that, it would be a 100% oil dump because each lifter has access to 100% oil through there. Now, in our drag and drive stuff, that is what we want. Let me show you. All right, so this is a keyway lifter. You see how this is a this is a 1095 Isky keyway lifter. That little offset is actually to clear the opposite side lobe while this one is riding on it, or to clear the cam journal. So they're so big. And what it does is, these are a great lifter. Okay, great bearing lifter, great. Okay, the things that I really don't like about them are this really is the bushing that goes in them, the keyway. So there's the key. Okay, this is not sized yet, so I can't put it in there. That little key goes right in there. That's what locates it, just keeps it from turning when it's not on the lobe, keeps that from turning. Well, you see here, that goes into our lifter galley right there, or in our lifter passage. And the oil passage deadheads into here, has to go around this little groove to make it to the next one. And then has to do the exact same thing. Go around to go to the next one. And then go around to go to the next one. So imagine there's a big oil galley the size of my finger in between this bushing and the next bushing, lifter bushing. In between this lifter and the next lifter. If anything gets damaged or hurt, or you send trash through the engine, how do you get that all cleaned out? How in the world do you can't run a brush through it because this is blocking the hole. Here's the oil passage right here. It deadheads. Oil has to go around it. It squirts a little bit of oil in through the hole right there. Okay. How do you clean out behind there if there's any kind of problem? The long story short is you don't. Period. You blow through it as best you can and you hope for the best. Hope that it doesn't have any trash that's stuck in it. Whatnot. And the other thing is, if I do have any kind of lifter problem and it gets stuck on the blows up a lifter wheel or does something weird down here, most of the time I can pull it right here and just pull those right up. When this thing is stuck down in the bottom of the hole and it's like that, it's really hard to get out. Then another little key thing, you might have seen me do this, is if we ever have a accident where like on Cletus's, I drove down there quite a long time ago here at 6 Summer 2024, and he had broken some lifters, and for whatever reason, won't get involved in that, but for whatever reason, had some bad lifters. Now, to be clear, SMXs do not have bad lifter problems. They do not. Tom Bailey has never had a lifter problem. He's the world's fastest, proven drag and drive, has the most amount of miles on an SMX. Clark has never had a lifter problem. I've never had a lifter problem. Only a couple customers have had lifter problems. Not their fault. I think there's something else going on about it. I've talked about that before. I'll talk about it again, but not right now. And what had happened was, when this wheel has a problem, doesn't get lashed properly, or it just has an oil failure, whatever it may be, any lifter, including this really expensive one, if there's not proper oil to it or something else happens, over rev limiters, whatever, doesn't matter, okay? Something happens, it blows this apart and swedges it out. Swedges this out. And what I had done on Cletus's was it was stuck in the bore. I could not pull the lifters up because the bottom of the lifter was swedged out. It was gotten really big, would not come up. So what did I do? I went here, right here, and I go with a hammer, bang, broke it, took the camshaft out, pushed the lifter out. Nothing was wrong with the lifter bore. Put a new set of lifters in it. Done. You know how you get this lifter out? You see that keyway slot? You don't. You can't push it down through with the camshaft out of it. You can't do anything. It is stuck in this bushing until you take the entire engine apart, manage to get the camshaft out of it, and then beat the camshaft out or the lifter out from the bottom of the engine with the crankshaft out of it. You have to flip it upside down like this, and you're going bing, 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 knocking it out. Then you got to take this out, machine or beat it out. You got to put a new one in it, size it, do the whole thing versus that. That's way easier to do on whether it was on the side of a road, in some gas station parking lot, Costco, Walmart, wherever you ended up making it to where you had a lifter problem, and you could fix it like that. 90% of the time, you'll be able to just pull them out. Worst case scenario is you could break them off and push them all the way through. So that's why I do that. Then the other thing is, well, these make so much more horsepower. The world's fastest, right here. And it can go faster. How much better do you want it to be? It's like, would you say, so like for instance, would be, those would allow you to do something different with the camshaft profile, which they do, and you could make another 20 horsepower. I don't care. 20 horsepower doesn't mean anything. You mean, so now we could make 4,820 horsepower instead of 4,800. I mean, it's just kind of ridiculous. So that's just a long way of saying this is all really good, and yeah, it is excellent. Even could make slightly more horsepower, not that we care, but we need to be able to work on stuff and make it functional. This is a very functional, well proven out last lifter. They just flat out do. Now, I had a lifter problem at sick week because I was idling around, stuck in traffic and driving with this astronomically low idle, and it had less than 10 pounds of oil pressure. Remember, any lifter, doesn't matter if it's this lifter, that lifter, whatever lifter, if you don't have enough oil pressure to them, have enough oil feed, you're gonna have problems with them. So I had a couple lifters that were starting to wear out. We took the lifters out. I just pulled them out, slid 2 new ones in, bang, done. That was it. And then we were racing again and finishing 5th overall at sick week. So anyways, that's just something I was show you about the lifters in between a keyway lifter, a tie bar lifter, how we're doing things there. Is there something that is technically, theoretically better? Yes. But this works properly, works great, makes all the horsepower we ever need and more, and is serviceable. So that's why we do that. So I'm going to finish putting these lifters in. Dog is going to freak out about whatever. And something flew by the door out there or something. Oh, no, there's somebody out there. Oh, it's Gary. He's got to go attack Gary. I'll lube these up, put these in, and then as we finish installing the cylinder heads, and I'll show you how we're putting on the rocker arm rails, how we're putting in our caps into our intake port. And so I'll show you all that coming up next. Alrighty, so going to show you the rocker arm stand system and how this works. One piece rocker arm stand, so the rockers aren't held on, just by one post or one pad or one bolt. 17 bolts, 16 studs hold this entire rocker arm stand on. So all of this, and if you notice, what it is it completely sits on flat surfaces. Now this is all clearanced for the intake runner and the plug. So see, this is right here. So it's formed and shaped to the runner. Then every pad sits and clamps on directly to flat on the cylinder head, including this one, which actually goes up into the cylinder head, into that pocket. So these things fit and you always have to, I've already fit and double checked these ones, but everything can always have, you know, when they're fit this close, sometimes you have to touch stuff and have to feel it, make sure that it's perfect. So this has already all been fit to this head. This is for this head, this side of the engine. All the rocker arms fit directly on this side of the engine. Everything is fit together, okay, very nicely. So always expect those kind of things, and that's why it does take so much longer to do a lot of things, because things I wish you could just bolt everything together, but it just doesn't ever work out that way. Okay. So I'm going to torque all these down. So, I mean, every one of these torques down to 65 foot-pounds. So torquing this rocker arm stand on, quite literally is the same as torquing down the cylinder head on like a regular LS or small block Chevrolet or big block Chevrolet. The cylinder heads on this, you know, get torqued to 125 pounds. These get torqued to 65 pounds, just like what a normal 7/16 stud does. Then we'll put in all the push rods, then start putting on the rocker arms. Now, as soon as we get to the rocker arm stuff, I'll talk to you about that real quick and how they're designed and what they do. Also, these Manton, when I give these guys credit on this, it's because they're due credit, but I actually developed this rocker arm stand with Trevor. That's Trevor Manton and his brother. Developed this because they didn't have one for this style cylinder head. So this is pertinent and goes with SMX. It will fit. I think it will fit on a Alan Johnson 41X, I think. But since my runner and some other things are different, I'm not sure how well they fit. I'm not positive. But here in a second, we'll throw the push rods in here, which are also Manton push rods. Custom deals, obviously. 1/2 inch to 7/16 single, or let's see, I think they're double tapered. And go through here, just double check. Well, I always think it's funny too that some of you guys that watch this must stop and zoom in so freaking close to look at stuff. I'm honestly impressed. Sometimes I go, the things you guys see, whether it's legitimately cracked or broke or not. Now on the SMX also, there's only 2 push rod lengths. There's an exhaust push rod length and a intake push rod length. There is no 2, and they are so far apart they're not even remotely close to interchangeable. So you never get them mixed up in anything. And worked on this rendition every time we build these. I go through and we make a little adjustment here, little adjustment there. You know, a little spot where we're clearancing or we're making something just a little bit nicer, a little bit better, etc. But you can see here, that's a double taper. So this is an extended tip push rod so this is actually a 3-piece push rod. Extremely good material. Oh, as my grandpa would say, that's harder as woodpecker lips. It's hard as woodpecker lips. Super hard. I don't even know what it's made out of. I really don't care. And then this is a cup style, so the rocker arms are a ball. So most of the time this is inverted. There's a ball here, and the cup is in your or in your rocker arm. You go the other way around. I'll show that to you when we get the rocker arm here. Intake's just a shorter version of this push rod. Just for kicks and giggles, I grabbed this for you too. So this is your SMX push rod, right? This is your LS push rod. Woo. No, we're not compensating for anything. This is just really small. And this is what's needed in something that makes that kind of horsepower. I see the rocker arms are held on by 2 shafts here, or two studs. These are a 3/8 stud. These get torqued to 45 pounds. And each rocker arm will fit. They're both the same. So they will fit intake and exhaust. And I wanted to make it that way just to make that easy, simple, whatnot. Now this one, because this is a, like I said, this is the original combo here. This one has a revised, updated intake rocker, standard exhaust rocker. The intake rocker is the hardest valve to open. Not going to answer why. You tell me why. Why is that? So it receives the most amount of abuse. We'll lash these, or just give this a quick lash. And then I always like to, everything's torqued, all the push rods are in. Do not, I have to stop Kyle sometimes. I'll stop anybody that works for me that is starting to put rocker arms on, and then they're gonna like adjust them while they're all on, and the push rods are like pushing them off, and they're not bolted down. Stop. One cylinder at a time. Put the rocker arm on, tighten it, just rough lash it. You don't even have to make it permanent because you're gonna come back through and torque everything and then lash everything, but do it one cylinder at a time. Now, that means do it exactly the same way when you're taking them off. Roll the cylinder over, top dead center, so both are loose. Then take them off, place them in the valve cover, place them away so you know exactly where they are. They're marked, they're in order. They can go right back on, zip, 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 be done, okay? Do not just come in and just start zip, 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 and taking all of them off, and you're backing this one off. Oh, I think I better back off the adjuster, and roll it over, top dead center, take one cylinder off at a time. That is the proper way of doing it. Can you do it other ways? Yep. Can you screw it up? Yep. So I have just zipped it down, just not overly tight, not torqued yet. Run the lash tool. Since these are brand new heads, they're actually a little thicker and haven't been repaired yet. And so I just run it down and just give it a little bit of lash. I don't even bother tightening it up because I need to come back and do it again. But I do this so that they're not too loose, that I can feel them, just get a good idea of where they're at. And you don't want push rods coming out of the cup or ball. And this one, like I said, is a ball style instead of a cup. That ball and the shaft through there is actually stronger than making a cup. So this is the stronger version. The cup up here is actually the weaker version. Has more of a tendency to break off. So don't want this stuff bouncing around, too much lash, and that's why I don't like to take all the rocker arms off without rolling the motor over. You just one at a time, put them on one at a time, and then you're being careful. So then I just do this in firing order. What's the firing order on an SMX, you might ask? 1-8, 4-3, 6-5, 7-2. What's that firing order, Nate?
Is that conventional? Big Rock Chevy?
Yeah. Conventional Chevy. Traditional. 70 years or whatever of glory. All right, if you've made it this far, you are dedicated. I appreciate it. You're awesome. So you see now, we went to Sick Week, finally got my crap together on the last pass of the day, of the week. But hey, that is what it is. And so now we're just ready to roll. So we're gonna be out doing some racing, and we're gonna keep you guys posted on all the stuff that we got coming up. So like, subscribe. I really appreciate all you guys. Have a great day.